Consider two sets of vector p and q, where p contains the vectors 1, 1, 0 and 2, 1, minus 1, and q contains the vector 1, 0, minus 1 and minus 2, minus 1, 1. And suppose that these are vectors in R3. Is the span of p equal to the span of q? So we are trying to determine if the two sets of vectors are equal. And to determine the equality of two sets, what we need to show is span of p is a subset of span of q, and the span of q is a subset of span of p. To show that the span of p is a subset of span of q, I need to show that every vector in span of p is also a vector in span of q. But there's no need to go through all possible vectors in span of p. In fact, it is sufficient to show that these two vectors in p are in the span of q. And the reason is because span of q is a vector space. If v1 and v2 are in span of q, then automatically the span of q will contain all possible linear combinations of v1 and v2. And so will contain the span of v1 and v2, where v1 and v2 are these vectors here. And I'm going to call these two vectors u1 and u2. So what we need to show is the following. In particular, we're just going to show that v1 is in the span of q, and the rest of the details for showing v2 is in the span of q are similar. To show that v1 is in the span of q, we need to be able to write it as a linear combination of u1 and u2. So v1 is in span of q if and only if there exists real numbers alpha and beta such that v1 is equal to alpha times u1 plus beta times u2. But that gives us this equation here. 1, 1, 0 equals alpha times 1, 0, minus 1 plus beta times minus 2, minus 1, 1. Now I can rewrite this as follows. So this is now this matrix equation. And I can solve this, for example, by row reducing the augmented matrix. But it's not so hard to see that beta is going to be minus 1 because of the second row here. Once you know that beta is minus 1, you can check that alpha has to be minus 1 as well. So that's a solution. So v1 can be written as minus u1 minus u2. Can now replace v1 with v2 and carry out the same procedure, and you also see that v2 is indeed a linear combination of u1 and u2. And that will show that the span of p is a subset of span of q. So what you need to do next is to repeat the same procedure and show that u1 as well as u2 can be written as a linear combination of v1 and v2.